Hello everyone. In this session we'll talk about Numpy library in Python. Numpy is an acronym for numeric Python. Um, so basically it provides functions, and there are a lot of stuff there for mathematical and multidimensional or array or matrices calculation related functions. So it makes our life very easy compared to what we can do through lists and dictionaries. And there is a lot of stuff here in this library, and which is very efficient also. So what it can do, it can give you a lot of functions which through which you can perform calculations in terms of multi-dimensional arrays, not only 2D but in 3D and more dimensions too. So uh, we earlier used to have two libraries. One is numeric and one is numarray. Those are both of those are now deprecated, and numpy was then later came into picture, and then we got Scipy and Panda as libraries. So we'll be talking about those things later in our session. So this is the first session. We're starting with NumPy. So we see here we have two commands for creating data. One is arange and one is line space. So to import NumPy library, you first need to install it because it does not come with default package. You need to install it through pay for easy install. Once you install it, then you can import it using import NumPy. And if you want to use an alias, so you can use import NumPy as any name which you want to give, so that you can refer it using that name. So here you see an example where I am creating a list of different floating point numbers. So you can consider these as temperatures, and I'll be performing some operations on each element of this list using numpy functions. So let's say A is my list, and now in B, what I'm doing is I'm converting this into array using np.array function. So if I print this, you will see that it is formed in this format. See, when I printed A, it was something like, or even when I tried to print A, it would print each element separated by comma, but you see a bit difference when I printed P, which is an array. Okay, now if I want to perform a calculation on each element of this array, what I can do is I can simply do like p multiplied by whatever calculation I want to perform. So you can see in output every element uh, uh, is now updated, and the formula is applied on each element. Okay, so this is the beauty of this library. If I have to do this same thing using lists and dictionaries, I need to use loop to do this thing. So for example, if B is that list, or if A is that list, and if I want to create a list, updated list, I will keep it in C. So I could have done it something like this: C equals x multiplied by 9 by 5 plus 32, same formula, and I need a loop for that. So I will say that for x is nothing but each element of that list. So for x in that list, which is A. Okay, so it will repeat for each element, and then it will create a list, and we will save it in C. So when I print this, uh, it should be square brackets, not round brackets. So I will copy. So with this, when I now try to print C, it gives me the same thing, though I can take care of precision and decimals later on, but the output is similar, or you can say. So when we talk about a range is again a function to create that data. So we'll see for a range we have different arguments. The first argument is start point, and the second one is stop point. So stop is mandatory, rest all are optional. So To create a list using or you can say range using np.arange function, just specify start point and end point, so it will create that array, right? So if I say 1 to 10, then it creates from 1 to 9. So this is the syntax for this function: start, stop, and then two more arguments. We'll see all these arguments one by one. So if I say for simple functions that we have in X in Python, the range function, if I do like bb is equal to range 1 comma 10 and I print it, it prints my output and this format, and you can see the difference. Okay, or this is just the difference in terms of format, but when we actually do operations in terms of different matrices and data analytics, you will actually realize the difference. You will see the difference, and you can uh, see the difference in terms of performance also. So if I say cc equals np.arange, if my range is starting from 0.5 and it is ending up to 10.3, if I want to keep the step size, which is the third argument, as 0.6 or 0.8, whatever, so it will start from my starting point, and it will try to reach to the ending point, but if the next step value is greater than the ending point, then it won't go further, and it will add up only those number of items. So okay, the next thing is line space, and the first argument for line space is uh, here you need to specify start. Okay, the second argument is stop. The next argument is numbers. How many numbers do you want? By default its value is 50. Okay, and the next argument is the endpoint. What is the endpoint where you want to stop? And the last argument is whether you want to return a step size or do you want to return the numbers as an array or a list. Okay, by default its value is false. Okay, so we'll see a few examples for this also. So if I simply say if I want to print 50 values in between any two numbers like 1 to 10, okay, 50 values. Now those values it will generate on its own. I do not need to define any step size, nothing. It will automatically calculate equivalent portions, uh, okay, and then it will give me a complete array. So for this I just need to write print, and then you can say np dot line space, and here you need to put 1 comma 10, and the default value for num is 50, so it will give you 50. But if you want to change, you can always change. If you want 100, you can provide third argument as and its value as 100. So next is if you want to define the number of items that I just said, so just add up the third argument. So then np dot line space 1 comma 10 comma 20 if you need only 20 items. So it will give you that array. Okay, next is uh, next what you can try is if let's say if I do print 1 comma 10, okay, and the third argument if I keep it as 9, okay, and then after that if I keep false, okay, or let's change it to true. If I run it, oh I'm sorry, it should be np dot line space. I just written the arguments, not the actual function. So np dot line space, and then something like this. So you see that it returns this is output 9 items in between 1 and 10. Okay, so it takes care of the step size automatically. Okay, now I gave third argument as the fourth argument as false. Let's see what happens then. So if I keep the fourth argument as false, it gives me a different output altogether. So what is the reason for this difference? Because in line space the fourth argument is endpoint. If endpoint is true, that endpoint would be included. If it is false, then endpoint would not be included. Okay. The next thing is if I do from 1 to 10, 50 items. If I say false, and there is another argument, the last one, which gives us step size. If we keep it false, and by default it is true. Okay. So if I change it to true, and there is one more argument which we have not yet covered. So it gives us a complete array, and you can see at the end, after giving all the elements, there is a number which is 0.16. It is nothing but not 0.16 but 0.18. It is nothing but the step size, the difference between the two consecutive elements. So ret size means it also returns size as output. You can see here. Fine. So another analysis that was done between Python lists and Numpy arrays. Uh, we took sample two arrays, right, and we stored numbers up to 1 to 100 using range function, and then in third list we are simply adding a loop, and we are adding the elements of x and y, and we are appending it in z. Okay. So at the end we will be printing the total time taken using simple Python list, or we have done the same thing using Numpy library. We used arange function and then we performed add operation. So it took 10 times lesser than the normal Python list. So in our next sessions we will be talking about more functions in this library, and where this library is actually used. We'll see some analysis, we'll be seeing analytics, and then further we'll be seeing how this data can be used by other libraries for plotting and other purposes. So thank you for watching this first tutorial, and watch our next video for further details.